as the question says, figure shows two blocks in contact sliding down an inclined surface of inclination 30 degrees. The friction coefficient between the blocks of mass 2 kg and the incline is mu1, that is here it is 1, and that between the block of mass 4 kg and the incline is 2, that is here it is mu2. Calculate the acceleration of 2 kg block, that is of block 1, if mu1 is 0.2, mu2 is 0.3, and if mu1 is 0.3 and mu2 is 0.2. The case to be noted is that here mu1 is less than mu2, while here mu1 is greater than mu2. Now moving ahead with the first part, we can see that mu1 is less than mu2, that is this is having a greater mu, so it will be having actually a lesser acceleration as compared to first block. That is, if we consider the free acceleration on this wedge, then block 1 will be having greater acceleration than the block 2. So we can say that throughout their journey, when block 2 comes to the bottom of the wedge, the block 1 will be pushing this block 2 in the downward direction. So if we note the forces on block 2, then we are getting a pushing force P over here, a frictional force F in the upward direction, a component of downward mg force which is equals to mg sine 30 degrees, a perpendicular component mg cos 30 degrees, and a normal reaction N2, and the acceleration A. So we can say that both 1 and 2 will be moving with the same acceleration A, since A will be pushing to B and both will be in contact throughout their journey. So framing the equation for block 2, we can say that mass into acceleration equals to total downward force along the wedge, that is pushing force plus mg sine 30 degrees minus the opposing force which is F. F we know as mu N2, and that mu is mu2 actually. Since there is no acceleration in the perpendicular direction, we can say N2 is equals to mg cos 30 degrees. Putting the values over here, that is mass as 4 kg, g as 10, acceleration as the variable, and p as the variable, and other things from here, 6 root 3 plus 4a minus p minus 20 equals to 0, marking it as equation number 1. If we calculate the value for this will come to be 20 root 3, which we have put up in this equation. Now moving on to the second block, we can say that the pushing force will be equal and opposite on both the blocks. So on block 1, the pushing force will be along the wedge in upward direction. Also the friction will be in upward direction because the block is accelerating in the downward direction. These are for block 1, right? So we have now the equation for the first block, for which we can say that mass into acceleration equals to 2g sine 30 degrees, that is mg sine 30 degrees, minus frictional force, which is mu1 n1, minus the pushing force. Now here also there is no acceleration in the vertical direction, so we can say n1 equals to m1g cos 30 degrees, giving us 10 root 3. Putting it in equation this, we get p plus 2a plus 2 root 3 minus 10 equals to 10, and marking it as equation number 2, let us solve equation 1 and equation 2. From both of these, we get acceleration equals to 16.15 by 6, which is giving approximately 2.7 meter per second square. Now, as I mentioned before that both 1 and 2 block will be moving with the same acceleration, both first and the second block have the acceleration of 2.7. Now, let us proceed with the second part, that is B part of this question. Now, we can see that mu1 is greater than